Okay, picture the scenario with me. You and the team have just spent months, literally months, implementing this beautiful, feature-rich application. You deploy it to production, the marketing team pushes it live, and suddenly the whole thing goes viral. Thousands of users are flooding in all at once. But instead of popping champagne and celebrating, your pagers start going off. The application just went down. It completely crashed under the heavy traffic. Look, as engineers, this is basically our worst nightmare, right? Well, welcome to this explainer, where we're going to learn exactly how to prevent this from ever happening to your code. Here's a quick look at the agenda for our explainer today. We're going to cover why load testing matters, JMeter basics and setup, how to add assertions, reading your test results, the difference between load, stress, and soak testing, and we'll wrap up with some best practices.
All right, let's jump into section 1, why load testing matters.
So the core problem we face every single day is that code behaving perfectly on your local machine might just completely fall apart under real-world pressure. And you have to remember, every second of downtime equals lost revenue and, more importantly, lost trust from your users. So what actually happens when your API suddenly gets 10,000 concurrent users overnight? Well, without load testing, that sudden surge is going to completely overwhelm the server's memory and CPU. You're going to see massive bottlenecks, locked database rows, and eventually a complete system crash. We absolutely must simulate this load and verify our system stability beforehand.
To really wrap your head around this, I like to use the restaurant analogy. Think of our API server as a bustling restaurant kitchen. The concurrent users are the customers currently sitting at the tables eating. The ramp-up time is the rate at which new customers are walking through the front doors. The response time is how long a customer has to wait for their food after placing an order. And finally, throughput is the total number of orders the kitchen successfully completes per minute. It's just like a real kitchen. If more customers arrive faster than the chefs can possibly cook, the service slows down, and eventually the whole kitchen halts entirely. Our job as performance engineers is to stress test that kitchen before opening night.
Moving right along to section 2, JMeter basics and setup.
To actually test our application, we're going to use Apache JMeter. This is the industry standard, open source, pure Java-based tool we use pretty much every day. Let's look at its core architecture. You can think of it like a nesting doll. We build tests logically from the top down. Everything lives inside a test plan, which is your master container. Inside that plan, you add a thread group, and this represents your simulated users. Inside the thread group, you add an HTTP request sampler. This is the actual action the user is taking, like an API GET or POST request. And finally, you attach a listener to capture and actually view the results of those requests. Let me show you exactly how to configure your first basic test. Let's say we're targeting the public JSON placeholder API. In our thread group, we set the number of threads, which, remember, is our users, to 10. We set the ramp-up period to 5 seconds. This is super important because it means JMeter isn't going to hit the server with 10 users at millisecond 0. Instead, it'll gradually introduce all 10 users over a 5-second window. Finally, we set the loop count to 1, meaning each user will execute the HTTP request just one single time. Once that's all configured, you just hit the green start button, and JMeter fires off those simulated requests.
All right, section 3, adding assertions.
Now, here's the thing. Simply firing off HTTP requests and getting a response back isn't enough, not even close. If a highly stressed server returns a completely blank page but slaps it 200 OK status on it, JMeter might think it's a pass, but the app is obviously broken. That's exactly why we add assertions. Inside your HTTP request, you right-click and add a response assertion. First, we set it to check the response code. We use pattern matching rules to ensure the code contains 200, which represents a successful HTTP request. But we don't stop there. We add a second assertion targeting the response body to verify it contains specific expected data, like an ID field in the JSON response. This is how we prove the database actually fulfilled the query under load rather than just returning an empty shell. And this brilliantly illustrates how we debug our tests when things go wrong. When you run the test, you use a listener called the view results tree. If the response is exactly what we expected, it shows up as a little green shield, a successful test. But if we tell the assertion to look for a 200 OK, and the server, under stress, throws a 404 not found, or maybe it throws a 201 created, but we explicitly expected a 200, JMeter immediately flags that specific request in bright red. It tells you exactly what failed and why. This is a game changer because it allows us to pinpoint exactly when and where the server starts struggling.
Which brings us to section 4, reading your test results.
Okay, once our assertions are locked in for a single user, it's time to scale up.
Let's bump our thread group up to 50 users, a 10-second ramp up, and 2 loops. To analyze this real data, we use the summary report listener. As a senior engineer, this is literally the first place I look. Let's break down these metrics so you know exactly what you're looking at. Samples is the total number of requests sent. With 50 users looping twice, we see exactly 100 samples. Average is your average response time, and it's measured in milliseconds. If this says 850, it means on average it took 850 milliseconds for the server to process the request and respond. And finally, the error percentage shows the ratio of failed requests. These are requests that either timed out entirely or failed those strict assertions we just set up. Listen, I want to pause here for a second because this is absolutely crucial. In a standard load test meant to simulate expected traffic, your target error percentage should always be exactly 0. 0%, no exceptions. If you're seeing even 1 or 2% errors during normal expected load, you have a bottleneck, a database lock, or some underlying configuration issue that needs to be fixed before that code goes anywhere near production.
Next up, Section 5. Load, stress, and soak testing.
You'll hear this a lot in the industry, but performance testing is kind of just an umbrella term. As you grow in your engineering careers, you're primarily going to run 3 very specific variations. Load testing is what we've been talking about so far, simulating normal, expected peak traffic to ensure the system handles it gracefully. Stress testing, on the other hand, is completely different. Here we intentionally push the system to extreme, abnormal limits specifically to find its breaking point. We actually want to see how the hardware breaks and if it demonstrates effective error management. Finally, we have soak testing, which is also known as endurance testing. This is where we apply a moderate, normal load, but we run the test for a very long duration, like 24 or even 48 hours straight. The goal here is exclusively to expose sneaky memory leaks and long-term performance degradation.
Finally, Section 6, Best Practices and your challenge for today.
Let's wrap this explainer up with a critical best practice that separates the junior developers from the senior engineers. When you are building and debugging your test plan, absolutely use the JMeter GUI. It's great for that. But when it is time to run the actual heavy load test, you must run JMeter from the command line in non-GUI mode. See, the JMeter UI itself is a very heavy Java application that consumes a massive amount of memory and CPU. If you run a heavy test inside the GUI, JMeter itself might bottleneck your local machine. That skews your results and gives you totally false response times. Always execute from your terminal using the command JMeter-N for non-GUI mode, -T followed by your test file, and -L to output the raw results into a CSV file.
So here is your challenge for today. I want you to go download JMeter, create a test plan with a thread group of 100 users, point it at the JSON placeholder API, add your assertions, and run it in non-GUI mode from your terminal. Once you're done, check your CSV results and share your average response time in the comments below. Look, load testing is the only way to guarantee our software scales flawlessly in the real world. Because ultimately, if you can't mathematically prove your system can handle the pressure, do you really know if it works at all? Get out there, start testing, and I'll catch you in the next explainer.